Every strategic decision a modern business makes relies on a single raw material: data. We funnel millions of disparate data points into streams of information in the hopes of extracting actionable insights. We like to imagine this information lives in pristine, perfectly ordered spreadsheets and relational databases. But real-world data is messy. It's scattered across raw text files, nested JSON structures, and unformatted PDFs. When tasked with analyzing this mess, most state-of-the-art AI systems break down. They are built to read neat rows and columns, force them to process unstructured files, and their logic fails. Compounding the problem, many of these analytical tasks are open-ended. There is no simple answer key or ground truth label to check the AI's work against, making it difficult to know if its reasoning is actually correct. Treating data science as a simple translation exercise, where a prompt goes in and code comes out, is a flawed model. Operating in the real world requires an agent built to survive chaos. Watch an expert human analyst work, and you will rarely see them write a flawless script on the first try. They test an idea, hit an error, rewrite the logic, and test again. Researchers at Google Cloud have introduced a new framework called DABStep, designed specifically to replicate this rigorous, human-like workflow. DABStep critiques its own logic. It takes the initial code attempt and subjects it to the same scrutiny as senior analyst would, identifying flaws before the solution is ever delivered. The system begins by executing its first critical innovation, the data file analysis module. Before attempting to solve the prompt, this module automatically scans every file in the target directory. It reads the unstructured text and nested data, extracting the necessary context to build a comprehensive textual summary of the environment. Skipping this step forces the AI to plan in the dark. In testing, removing this initial map caused the system's accuracy on complex tasks to drop to near 26%. The primary operational loop begins. A planner agent drafts a strategy for the coder, who translates it into an executable script. An LLM verifier reviews the code, rejecting flawed logic. This rejection activates the router, which diagnoses the error and forces a retry. By enclosing these agents in a continuous circuit, the architecture prevents small mistakes from compounding. The AI dynamically debugs its own logic until the verifier is satisfied. We can see exactly how much work this closed loop is doing by looking at the system's telemetry on the DABStep Data Science benchmark, which tests both single-file and multi-file tasks. This chart tracks the average refinement rounds to reach a solution. Easy single-file tasks average just 3 rounds through the loop. But hard, multi-file tasks force the system to grind, requiring 5.6 iterative cycles before approval. If the system relied on its initial guess, it would have failed hard tasks entirely. Complex analysis demands engineered persistence. That persistence directly translates into measurable performance across the toughest global evaluations. This chart shows DABStep mapped against prior baselines like AutoGen and DA-Agent. The new framework raised accuracy on the DABStep benchmark from 41 to 45.2%, taking the #1 rank on the public leaderboard. It also secured clear victories on KramaBench and DA code. Because the framework is model agnostic, these results remain consistent across different base models. The architecture handles the iterative reasoning, allowing it to leverage various LLMs for both easy and difficult tasks without losing accuracy. The ceiling for artificial intelligence is no longer dictated by language generation. The new standard requires multi-agent collaboration and rigorous self-critique. Beyond the benchmark scores, this shift has practical implications for any organization staring down a massive, messy directory of files. The most effective tools moving forward will evaluate their own logic and have the resilience to iterate until they finally uncover the truth. By bridging the gap between natural language prompts and verified executable code, the system absorbs the technical complexity of the workflow. Because the AI handles the grueling trial and error of debugging, the user can focus entirely on the high-level inquiry. Data science is no longer limited to those who can write the code. It belongs to anyone who can ask the right questions.